This video shows how to test the normality assumption as a requirement for the paired sample t-test. First question: what has to be approximately normally distributed? The residuals. Here, residuals are the difference between the two measurements for each individual. They need to be calculated first and saved into a vector to further work with it. For context, I have the long format for my data and the time variable is called t and the test variable v. For calculating the residuals, use the width function. Start with your data frame, then the individual differences for the test variable will be calculated based on the time points in square brackets. Now there are three possibilities to test the residuals. First, an analytical test like the Shapiro-Wilk-test. Second, a histogram. Or third, a QQ plot. The Shapiro-Wilk-test is oversensitive to unimportant deviations from normal distribution in large samples. This is a phenomenon for all analytical tests, for which you can find a source in the video description. A QQ plot, however, is the easiest to interpret. Therefore, we continue creating one for the residuals. In order to plot the residuals, I strongly suggest using the ggpubr package. Use the insta.packages and library function to enable its functionality. We then use the ggqq plot function. Simply put the vector with the calculated residuals into the function and run it. The graph you'll now get has two main features. First, the dots that represent the observations. And second, the line that represents the perfect normal distribution. Here, the distances between the dots and the line should be minimized. Again, there will be acceptable deviations, especially on the edges of the distribution, meaning the upper right hand corner and the lower left hand corner. For my residuals, deviations are not of concern and I can calculate the paired sample t-test now, which is shown in the following video. If you, however, cannot observe an approximate normal distribution, you should use the paired samples Wilcoxon test instead.